So please welcome Daniela.
Thank you. Thank you so much. So yeah, I'm Daniela. I'm a principal software engineer at JP Morgan. And yeah, I already saw like when I was getting in, some people looking at the program and saying, production ready hello world. What does that even mean, right? But what it means is that we're here to solve the most important problem in computer science, which is how to do a very good hello world program. An amazing hello world program. No, that's not the point. The point is I chose this very trivial example because I didn't want to distract us from actually the first part of this talk, the title of this talk means, which is what is production readiness? And this talk was actually heavily inspired by this article, which used to be very popular a few years ago, which was written by Google in the hidden technical debt in machine learning. And if you look at this diagram here, you can see this tiny little black square that you cannot read, but it says ML code. That's machine learning code. And the whole point of this article can be summarized by these images, all the other things that are necessary to be in place for you to put a model in production. So you have like a configuration, data collection, serving, analysis, so many other things. And the first time I saw this, I thought, you know what? Isn't it true for literally everything? When you think about it, when was the last time someone came to you and say, oh, can we do this this task now for, I don't know, next sprint? And you say, no, yeah, okay, can be done, okay. A couple of days later, this person comes back to you and say, hey, we're on time. Is it done? You say, no, yeah, totally done. I'm just missing the tests. And you get, then you need to breathe in and say, yeah. So, okay, they are not quite actually done. And this is the whole point. So what are the things we need to consider when putting something in production that are not necessarily explicitly say the task at hand, that are tangentially related, like non-functionals and other things? But before I get to that point, I want to digress a little bit. And I'm going to talk about something I'm very passionate about, which is called coding katas. If you're not familiar with the word kata, no worries, this is a martial arts concept that you can often see like in karate, judo, and other martial arts. And the idea of a kata is a sequence of movements, kind of like a choreography, kind of like if you think of a dance. But the important thing about a kata is that kata has a concept called bunkai, which is the application of the kata. Kata is a sequence of movement designed to teach you something. They are designed to teach you how to block, how to punch, how to do something, martial arts context. Why is this important? Because there's also something called coding katas, which they are inspired by this. I think the most famous coding kata, as far as I know, is called the Gilded Rose kata. And here I'm linking I'm going to share the slides later if you don't need to be too attached to that link. But here I'm sharing the solution by Sandy Metz. She's very popular very famous in the Ruby world. And it's a brilliant talk. I highly encourage you to watch this later. But you have katas for everything. So you want to practice refactoring. You want to practice, I don't know, object-oriented programming. You want to practice some things. Here is a list that you see the awesome katas where you can find all sorts of things, all sorts of languages. And when I was thinking about production readiness, I thought, what if we had a production readiness kata? And that's why I came with this problem statement, which is, OK, you're just joined a team, and you are in charge of developing an application called Ping Pong. This application is on a web server that listens to a request, and if it receives a GET request on the /ping endpoint, it should respond with the message Pong in JSON format. It's intentionally vague, and sometimes we talk about this especially if you see senior software engineers' job description, you see, oh, deal with ambiguity. That's the whole point. Like, this is very ambiguous, very open, so you can play with the idea. But the catch is the code should be production ready. And I like to do this from time to time with my team, and some of my colleagues are here. I usually add a constraint that if you're doing in Go, I only want you to use the standard library. And that's designed because I think from a practical perspective, the more you leverage the standard library, the better, less dependencies, less moving parts. So that's the idea, to encourage that. And also, give us from a kata perspective, helps you deal a bit with constraints. I think the original problem is not constrained enough, so adding some constraints makes it a bit more interesting. So, typical implementation of the hello world problem, not much attention for details, so you just like, maybe this could be, even if you ignore white space, you can summarize this in 4 lines of code. My question to you guys is, how do we evaluate this version from a production readiness perspective? If everyone here is raised and agrees that this is production ready, okay, we got 30 minutes back of her time, let's go have a coffee. But hopefully, you all agree with me that this is not quite right. Okay, then what is production readiness? And again, this is one of the favorite interview questions I like to ask people, because if you ask 10 engineers, you get 11 different answers to that question. And one that I heard recently was a very minimal answer, and it was typically like this. Oh, yeah, it compiles, passes the test, does what the user wants to do. Who thinks this is a good definition? OK. So this kind of touches some of the subjects that I care about, but I would consider a better answer to be something more like this. Software that satisfies the business needs of performance, correctness, and what's especially ignoring this part here is maintainability. And what I mean by that, and why I choose those 3 words, is because they touch the non-functional aspect of code, of the product, so in terms of availability, response time, latency, throughput. But in the correctness side, it touches the aspect of, yeah, does it really do what you're expecting to do? Because there's no point if it doesn't. But also, we often ignore the negative scenario, which is, are you protecting those things that it should not do? Like, is it doing more than actually asked for, or maybe some corner cases? And this is actually something Bill mentions a lot here in his workshops about how important it is to have the code work in your favor in a bad day. Also, so maintainability. Okay. If I'm writing for myself and try to make my life easy today, where I'm actually nothing is on fire, that's one thing. But if you're having a bad day, I don't know, you're selling Taylor Swift tickets, and your customer is on the line saying, "Oh no, I cannot get my show tickets, and you need to sell." And yeah, so a lot of pressure, management, customer, and so on. You need to make your life easier for that moment. It's not so important to make your life easier now. So. And this is, I think, is the most overrated, like the most forgotten concept of production readiness. So in terms of, again, another concept that you can Google, easy Google it, and find hundreds of different checklists. I just summarize it. It's very simple here. Does what it's supposed to do. That's kind of obvious. But is it tested? And I always like to say that tests are your insurance policy. Something that doesn't have a test, by definition, it's not production ready. Why? Because tests are the only thing that guarantee that you have the freedom to play with the code as much as you want, because the test will alert you when you've gone too far. So this is why I strongly talk about insurance policies. Yeah, can you put your hand on fire if your tests are not protecting you? So you'll be taking much more risk by making changes. But also, is it configurable? Does it provide runtime information? Like how many times are you stuck into debugging something in production and say, oh, does this really match the code that I'm reading? Does this match the version? Or is it the version I'm expecting to be testing? And sometimes you say, oh no, this is running the old version. We forgot to deploy or something else. And also, of course, error handling. There's nothing that annoys me the most than that error message where you say, oh, something went wrong. Please try again. If it doesn't work, come back again later. And you say, what the hell? What went wrong? Give me something that even if I'm a customer, I can reach out to support and say, I saw ID X. Give me something more than that. So this is also a consideration. So for the next few minutes, we're going to have a look at the hello world kata in Go, and this, again, I'm going to touch the basics, but this is an open-ended exercise. I encourage everyone to do, and everyone will come with a different answer. So this is the original version we saw there. So it does what is says on the tin. So if I say run, let's say this is probably too small. So let's just, so I say go, run, main go. What's the first thing you'll notice here? Nothing. Yeah, you cannot see. You cannot even say, is this running? Is this blocked? Is this a problem? So you have nothingness. But if I try to curl this, and I say curl HTTP, let's see, local host 8080, I might get something. Okay, how do I know 8080? I have to know this because I know it's in the code, but also there's no hint that something happened on 8080. And if I hit /ping, then I get this, oh, I got some noise there, but okay, I'm getting a pong back, so we're done. No, we're not. Okay, first rule of anything, before I touch anything, I add some tests. So I'm going to write the most silly test I can think of, which is this one. So I'm just going to trigger main in a separate Go routine, and you can see question marks here. What? Is this really a good idea? After you do this, I have no control over main. Can I kill it later? Not necessarily. So I cannot run this test in parallel, otherwise I'll throw thousands of main functions over there. So this is not a good idea, but okay. I just need to start somewhere. And this test actually runs. Oh, unfortunately it's cached here. Let's try to run from the command line instead, because I don't know how to clear my cache at this point. So let's force one time. And I have a pass, and even better than that, oh, I have some fairly decent coverage as well. Okay. Yeah, if I see here. But, okay, I'm deeply annoyed by the fact that this is running Go on a separate thread. Can we do something about this? And I really enjoy this is something I'm reading in some of the Matt Ryer's blog posts recently. He posted a blog post, things I learned about after writing APIs for last 13 years or something. And he talks about the separation of main and run in two parts. So you have main just triggering a function that's run, and run does the groundwork. Why is that? Because then run becomes testable. You can simply check for an error return, and here the responsibility of main is just setting up the context and calling run. So I have a bit of modularity here. I'm just spawning my server in a different Go routine, and just this will basically block forever. So I kind of have some control, and this helps me write the test, because now I can just, at least I can put a timeout and kill that main after some time. It still will be, I still cannot parallelize this because I have some other problems to care about, like this is hard-coded in the same part. But let's deal one problem at each time. You know, see here now I also did the work of separating the handler in a separate function, because now I can start using a different strategy to test, which is HTTP test. I can simply call that directly, and instead of a Big Bang test that tries to do way too much. So, and here, of course, the only way that I can escape from main now, or from run, is if this context is canceled, which you'll notice that it's not in the main program. For now, I'm just fixing the test part. And for the rest of it, yeah, just testing the message. This test is passing. If I run the package tests, yeah, you see, I already have this running somewhere, which is actually this one that doesn't tell me it's running. So you see how quickly this also affects your development process. It's easy to forget you have a process running somewhere. And OK, so what's the next thing we can do is, let's make this context work in our favor. And one of the things we can do is trap the signals from the operating system so we can get a bit more friendly with the machine. And typical signals we capture here, OS interrupt, OS queue. But you can also be a bit more specific and have like a signal, I don't know, sig term or others. But for this scope, let's focus on these two. And we will see that basically the rest of it is basically the same. But we have at least a bit of a better groundwork here. So go run main go. Oh, main.go. OK, I tried to do way too many things at the same time. Go run main.go. That's how you know it's alive. OK, still annoying. I still don't know if anything is doing here. I can curl this, same response, but at least if I do a Control-C, now I'm capturing that signal, and I have a bit of more friendly API. I'm starting already to see some logging happening, so some information, at least when errors happen. But still, I don't like this radio silence here, so let's fix that. And for the next step, we can, I usually like to add some runtime information. One of the things is that helps you diagnose maybe how many proxies you are running, and especially if you're running into Kubernetes or something that you can change this externally. But also it's useful, maybe you're facing some weird bug, you know which runtime version you are running. Is this Go 1.22, 1.23, and so on. So you can use runtime and debug packages to extract some nice information here. There's also something that's very common is to insert build time information, because you also want to know that you're testing the actual version you're seeing in the code. And the way we do this is we can add some build variables here. And the way these variables work is at compile time, you can use go build command to inject a different value here. If you're not using go build, this will be by default named develop. But I can use some clever makefile magic to change this value. So for now, so we're adding this 3 log lines. This already gives us a hint that this is running. So let's see here. So cd step 5, go run main go. You see, OK, server version is develop, because this is development time. But let's say you want to say something else. I never memorized this command completely, but it's you can use this flag called LD flags, -x, and then you can say package.variable name, and here you can do 1, 2, 3. Let's close this. The package and variable are on single quotes. You can put double quotes here. So I'm building a version. These LD flags will change the value of that variable here to whatever is passed on the command line. So here now I know that if I just instead now of using go run, I'm going to use this, and now I know I'm running server version 1, 2, 3 instead of develop. And you can use this some makefile magic to use your last commit tag or something else. And here's an example. I have a makefile where I'm adding this version variable here. And this is a makefile syntax for use this as default if you don't assign a value. So let's just run make build in this case. And I can run this again. So you see the version. I didn't specify any version, so you use that default value. But I can say make build version equals 1, 2, 3. And it will replace that for me. Another way of using this is, like I said, like in another step, I'm using some git magic here to get a commit hash. And then you can know, OK, you can strongly correlate the thing that's running in production, what the actual source code in the repo says. So, OK. For the rest of it, we still have a lot of things we need to care about here. But let's focus on this part, which is I know I'm running, but I don't know where I'm running because I have a hard-coded argument here saying like, where's my address? So what you can do about it is make this configuration. So one of the things I was talking about production readiness is less hard-coded things, less magic numbers, less magic strings. And here we can, by making this a configuration, it look like the same logic applies. So we have the main function as responsible for get those inputs, and now we just instead run to add whatever arguments we want to configure, and this makes easily testable if I want to try it with different addresses and then spawn, I don't know, several tests in parallel and so on. And here, now also I can start logging where I'm actually listening. Otherwise, I would just be repeating constants everywhere, which of course is not always true. So let's see. Step 6, go run main go. So now, yeah, now I know it's listening on 8080. I can change that with a flag, and here, of course, still the same thing. If I want to say pass a different address, then I can basically just use a flag. Step, and I can simply configure that. Now I have way more control. Okay, I still have lots of things that I'm annoyed, but let's focus on one of the things that's here, that I'm using the default HTTP handler. And this by itself, it's okay if you're doing like a pet project, you're doing your pet hello world. But what about if you're putting this in production? And here, think about it. Everyone can register anything to the default server mux. So it's a good practice to actually initialize your own. And that's when we start refactoring this thing a bit. And you know what? Instead of using the default server mux, I will actually create my new service function, and I will use a custom, like initialized by me, server mux, where I have much more control. So this, for now, is just a type where I have a mux. But I could have all my dependencies here, database, and so on. And new service is pretty simple. I instantiate the service, assign a new mux to it, and I do a setup routes function that will register my handles. And this is, I think it's a nice way of doing this, having this routes.go, because you have one place where you can see all your endpoints. It's more from a diagnosis perspective. Think about, again, that bad day. I want to know, well, where is the implementation of ping? Oh, it's here. I can just drill down and see that I have handle ping here. Another thing that is not important in this version, but also something I like to do, is have kind of a constructor function for your handlers. So instead of having the handle function directly, I have something that returns a handler, and this allows me to put, if I need, like some dependencies here, maybe I want to add a logger, maybe I want to add a database, so I can create this and return a handler that will implement, do the things for me. It's also this style of programming, I'm not going to cover that, but makes it easier for you to adapt middlewares if you want to attach something and compose functions in a functional way. Okay, so I feel I undid lots of things that I didn't want to. Okay, so for step 7, this is essentially the didn't change much. So 3, step 7, go build, and I just still running the same thing, doing the functionality. I didn't change a lot, but now this is a bit more modularized, and you can see I started separating the tests as well. But we still have the big question is that, okay, this is not much of a handler, right? I'm just returning a hard-coded string, so it's far from ideal. So, of course, the next logical level would be to fix that. And you can see in the next version, that's exactly what they're going to do. So instead of just returning a hard-coded message, actually, we're going to implement a proper handler. And if you remember the problem statement, we're talking about, I want it to return a JSON. But that actually the content we have been returning so far is not really a JSON, it's just a string. So we can see that if I query the previous version of ping, I'm just getting content type of text plain because I didn't specify anything. And if I can even say, oh, I want a header content type application XML, for example, ignores completely, doesn't say anything. I can make it this post method. It doesn't do anything. So basically, this is also, remember that it's not only important to do what's supposed to do, but it's important not to do what's not supposed to do. And originally, by definition, it's not supposed to respond to those things. And this is the kind of consideration we're taking here. So for this function, let's break down a lot of things is happening here. First, I'm adding some logging information that says, oh, actually, now I can know if I'm receiving requests or no, and I'm processing them. But also, I'm going to actually process the content type. And I'm giving some leeway. OK, if you didn't specify anything, let's default to JSON. But if it's a different than JSON, OK, I'm going to return a status not implemented message. And if it's on the method set, if it's a get, I can return a response. If it's not, we have the method not allowed status. So we can play with that. OK. Step 8, go run. Oh, let's just make build in this case. And this make build version is the one that already, you can see, it's using some Git magic, so I can see that this is the commit hash, the short hash of my commit. Oh, it's complaining that I'm mixing my windows here, so I need to kill that. And I can run it again. So yeah, it starts to feel like more something that's more production-like. And if I say curl localhost 8080/ping, returns the message. You see, it doesn't have that dirt at the end. It's just because now it should be responsive with the proper content type. And of course, I can try to ask it for content type application XML. And I have a nice little message, not implemented, and also my status is 501. And here I can also show how I'm using a method post. Also, method post not allowed. And if you look on the other window, now I can have some nice information that this is actually doing the work I was expecting it to do. OK. Also, a few things that I like here is that whenever I'm using this, let's say, builder pattern to build my handler, you can always use this space here in between before returning your anonymous function to define some things that will be helpful to you. And here, a good use of this is define a custom response type and not pollute the entire namespace if you're only going to use this response type here. It also makes it very simple for me to encode the response, so I'm using this local type. And some people might say, oh, but yeah, what about the tests? Don't I need to use the same type for the test? Not necessarily. Here, actually, when writing the test, you can have a local struct selecting only the methods, only the attributes you care about. So I'm only testing the message. So I only need to decode this body to this particular struct. So you don't need to use the exact same struct. And if you compare it with the previous version that was just trying to do a comparison on text, and this is usually a bad idea, because here this test will fail, and it will fail with a very weird message saying, oh, I expected Pong, but I got message Pong. And you'll see, you can stare at this for hours and forget what's the problem here is that the way this response is rendered, includes a space here. You can literally start for hours without getting this. So that's why it's important to try not rely. Oh, maybe I did something else. Oh, yeah, that's a good one. For some reason, yeah. And you see, oh, there's more. It's the other test, probably. I don't know. You see how debug is, how annoying is to debug this kind of thing? That's why you should use type safety thing. So here in the second test, you can simply decode to your string and only look at what you really care about. I'm not going to try and find the zero now, but you got the idea. Yeah, oh, so curious. So the temptation to fix this now, it's bigger than me. But no, let's make some progress. When you're here in the stage, there's only so many things you can see at a given time. But of course, there's a better way now that we have many, much more functionality. We're just not caring about that single string. So, okay, typical Go test. Let's make it table-driven. Then you can play with ideas of, oh, what's my test? For this method, I'm checking this status, this message. For this method, this status, and so on. Then here you can have a bit more test coverage. And one of the things I didn't follow through is that the test coverage for this project will tend to evolve from 100% to 50% to 7%. So as long as I'm changing. And one important thing is see test coverage as a helper thing, but doesn't mean that less test coverage is worse than best test coverage if your tests are better. That's the whole point of it. So I'm not sure what's the current coverage metric here. Go test dash cover. So we have like, I don't know, 80% of coverage. That's still pretty good. But don't get too attached to that. Sometimes when they're evolving something, this metric, you simply have more lines of code, and you might get less bang for your buck in terms of coverage. But that's what's important is the functionality and having that safety net. So the last step here is more like reshuffling things around. So at the point where you have this package here, you have routers, you have service. Everything is in main. When is a good point to start breaking things down? When you get your namespace start getting a bit too polluted. So here I just created a new service package to accommodate and start isolating this. If you are really a purist at this point, you'll say, oh, this is should not even be in service, should be internal service, because this should not be really imported by anyone else. But I'm happy at this point, and of course, adding a little bit of documentation and so on. Hopefully, at this point, you realize that this could go forever, right? I can keep polishing, keep improving. And there is also a very philosophical question is, when do you stop? When is good enough? And I'll say it's really hard, but it's definitely is not go all the way to, I'm not going to deploy this to production until it's 100% perfect, but it's not the first version as well. And this is something you learn with time, and everyone has their different answer to that. So, few notable omissions. Okay, this is pretty light on documentation. If this was a real production server, you want to do some documentation here. I really would like to add like a health check endpoint, for example. Health checks are very useful if you don't want to hit the actual API, but want to know that that thing is actually alive. For this one is, yeah, I know it's pointless, but isn't everything in this talk actually pointless for a hello world? But this is the exercise. This is the kata. Having a debug endpoint to see these things through if you need it. Adding some feature flags to when you want to enable debug or not. Middleware. Literally, this can go anywhere. I think the main points of these talks are these. So why I'm talking so much about katas and doing this, and I think everyone should do this from time to time, because we are in an age that we're talking about training AI, giving data, ChatGPT, Copilot, how much we use that. Oh, this makes our life so easy. We don't need to write code anymore. But we are forgetting to train the most important neural network, which is this one. It's your brain. So doing a kata, doing something like this, an exercise that helps you train a bit detached will help you give different perspectives on something that you might not see if you are too distracted by the task at hand. That's why Hello World was a trivial example, but just to exercise this muscle that we tend to forget. And of course, everything has its own technical depth. Everything. It's hidden technical depth. So think about non-functionals. Next time you are estimating something, remember that this discussion, remember that, okay, did I think this through? Did I think, when I gave the 2 days estimate, I was thinking about tests. I was thinking about the effort I have to put this in. An actual live production system. And yes, if it doesn't have tests, it's not done. Of course, we are hiring. If you're interested in putting a bit more interesting things in production than Hello World, we still have lots of power banks outside. If you want to see us, come have a chat. And that's it. Thank you very much. Hey. I think.
Do we have any questions? Really, no questions.
One?
What is ping.sh? In that
the mysterious ping.sh is that I was very worried that I would forget how to do. Oh, wait, not this. This is not ping.sh. I was very worried about forgetting my curl syntax, so I had these helpers. And anyway, that's a bit of the behind the scenes.
Okay.
Anything else?
Yeah, any more questions? We have like 25 minutes, so if you have any questions, go crazy.
Oh,
okay.
one there.
Since we're talking about production, would you delegate a lot of the things we could do in middleware, such as stripping out headers or cores, to sort of cloud firewalls or load balancers or things like that? Stuff before it hits go.
I'm sorry, can you just repeat? Like, I think I was a bit low on.
So instead of handling things like cores or stripping out headers or content types before it hits the Go binary, would you handle these on the edge or in API gateways, for example, on the cloud?
I think it depends on the case. This is kind of typical consultant answer. It really depends. But I think you can. You need to study on a case-by-case basis. But of course, I've seen like cores, for example. There are cases where we handle on the code, like a middleware. And but I tend to reserve middleware for something that I want to just modularize my code in a way, like for logging, for error handling, and things like that. But yeah, I don't have a definite answer for that. I need to think about it.
Okay, any other? Yeah?
Hello, thank you for the talk. I'm pretty new to software in general.
Okay.
And a few of my colleagues, the more experienced ones who's been doing it for years, they've always given me the tip of when you write your code, or you're going to write a script or a project or whatever, you write, it's quite similar to an entire system where you have system engineers that write requirements before. Do you encourage to write tests before you write scripts? Because it's one thing to keep going back and you've done this great script, and like you say, when is it production ready?
Okay.
And then you go in and you write your tests, and you're thinking, okay, well, I can keep writing tests because you can keep getting creative. But when do you know, when is that, okay, it's ready, for production? Well, back to the tip that my colleague gave me months ago was to write your tests first.
Yeah.
Do you encourage that? Do you agree, disagree, or what are your thoughts on that?
I'm not very precious about writing first or after you wrote your first implementation, but I think, like I said, nothing is done before you wrote the test for one good reason, which is your tests are the first client of whatever you wrote. It's your first chance to see from a different perspective. Almost when you're thinking from the test perspective, is looking from outside the box. So how can I call this function? Should I pass 3 arguments or 4 arguments? Is this a good experience? Is it a bad experience for the user that's going to call my code or my API, or depending on the level we're talking about testing? So some people prefer the TDD approach, which is the one that you're describing, is that I'm going to write the test first because they'll help me think about the problem. But I think everyone thinks differently. It's perfectly fine for me if you, no, I need to at least write something so I can get a better understanding of the problem. And the whole part of the design process of this person is like that. Okay, I need to see things running. But then at some point you need to stop and look, okay, this is how I think it should work. But what if I were like a second person and were calling this? How would they feel? And one of the things I realized at this point, you notice that, oh, you know what? This code is actually super hard to test, for example. And for my experience, there's a high correlation of the code being hard to test and being difficult to maintain. So at that point, you say, okay, I made something that passed, that works, but it's hard to test. You might need to redesign to make it an easier, more testable way. And this also very often produces better code that's easier to maintain. Right, so this is kind of my thoughts on this.
Hey, right. Thanks for the talk. You said at the beginning, obviously, this exercise is using standard libraries to do this example. Are there any external packages you do like to use or favorites that you might suggest to do some of these things?
Really, again, it's also another it depends type of question, depends on the domain I'm working. For example, if you asked me this 1 year ago, we didn't have like the new HTTP handler package and standard library, so using Gin or Gorilla Mux or something for that server Mux would be probably my first preference. But now I'm trying to force myself to learn how this new way to work with standard library. That's why I tend to default to standard library because then I can get rid of dependencies. The less dependencies, from my perspective, it's better. So yeah, I would say another one was Zerolog until not so long ago. Now I have a slog, so I'm trying to force myself to use slog. But yeah, at top of my mind, another very popular one that people like is, I don't know, Testify, Assert. I'm not a fan of those packages. I think you can do everything with this standard library testing package. So again, my personal preference, I think different teams will choose to work in different ways. It's also important to, as much as you have an opinion, what works better, not only for you, but for your team. But essentially, it's all about that point where, is this in production? Can we maintain it? And sometimes it goes beyond what you believe it's right.
You inject the git shar from the make file, but just so you know, they added a thing, so Go build does that automatically now.
Oh, really?
Yeah, there's a function on the runtime debug, I think, that pulls it out, so you don't need to do that anymore.
Oh, nice. I didn't know about that. Thank you.
I think it was quite recent, but yeah.
Yeah, I didn't know either. Thank you. Where was the second question? Yeah.
Thank you for your talk. One of the things you mentioned was error handling and how you don't like to see like something went wrong in the client side. So what is like a better approach from your side? Like how would you approach something going wrong and you need to give a response to the client, but you need to, it goes from the back end to the front end. And how do you map it in the business to, make it meaningful to everybody looking at the error later to debug it? Does it make sense? Sorry.
It does. I think that, yeah, the space I work in platform design. So I kind of, type of products I build is products for other developers. So I kind of tend to not worry that much about it because I just want to be as informative as possible, that if either the person can figure out that on their own, oh, I call this endpoint with the wrong arguments, for example, very simple, trivial. Or like if you get like a 500, at least I need to know like, oh, you got a 500 because database was, something happened with database, something happened somewhere. If it's client-facing, probably, yeah, it's a kind of a UI conversation with the UI team. How much do you want to expose? And of course, we are in banking. We don't want to expose almost anything. But giving some sort of ID that you can track back to, like internally, your support team can say, oh, this is the ID, like the trace ID, for example, or something. This could be a way out of it without leaking too much. What I think is really terrible is when you give a message that you have no way to follow up. Like, oh, something happened, try again later, and then you have no idea if you did something wrong or if it really was an outage or something that was properly internal. I've seen some companies adding contextual information. Oh, something will go wrong. Click here to open a ticket, or click here to see the docs. So you can give some contextual information in that sense as well.
Hi, thank you, Danny. One thing I noticed when you were talking about the tech debt, one time I was working on an application, or basically it landed in my lab, and it had been being developed for a long time, and it had 0 tests, nothing at all. And I was tasked to decide whether I were to rewrite the application or to kind of start building more features into it without writing any. I think the conversation with my manager was, like you said, the application is not production ready, but it's a throwaway application now. And I ended up having to spend 3 to 4 months just rewriting the whole thing with tests, and I ended up refactoring many of the code. Question is, having to deal with a bigger system or a bigger kind of application, would it ever be production ready if I were to start implementing features and try to hack my way writing tests? Or
okay. I got it. So there are a few things that we can consider in this kind of scenario. So when I talk about refactoring big systems, one very popular approach, at least in the agile world, is what we call an anti-corruption layer, which is essentially you're trying to factor out pieces of that old system that are still relevant and important. Let's say I have an account service and I have I don't know, a customer service. And customer depends on account or something like that. And it's a monolith, and I want to break down customer into own microservice. What you add is a layer on top of it. That's the anti-corruption layer that will basically route your thing. Say, okay, if this request needs to go to old world, it goes to the old monolith. But if it's something that talks about customer, I can already route it to the shiny new thing. So this is one way. And one thing is, we do when they're factoring out of this thing is also you can cover parts of the legacy in terms of testing, just to make sure you're not breaking behavior when you're deleting the code or disabling the code. Instead of deleting, maybe you just want to disable it, hide it in a feature flag. So then you start covering in tests just to make sure you're not breaking anything. But it should be an incremental step. And I think the anti-corruption layer is an architecture pattern that can help you in this kind of scenario.
Amazing, thank you so much.
Thanks. Anyone else? Sorry, I'll give you the mic, because then you can be heard on the recording.
I believe Martin Fowler called this pattern the strangler fig pattern, which I found really cool name. So just wanted to share that.
Oh, I see. Thank you.
Thanks. Any other questions? I'm curious myself. You mentioned that you don't like dependencies on external libraries. What is the context to that? Is that because you're working in the finance field and you want to keep things more like under control?
No, it's a more a personal preference, but the answer, you partially answered that. Exactly that. At least, I mean, we're writing Go. If you cannot trust the Go compiler and the standard library, what are you going to trust? But I think if you, I'm not sure if everyone remembers here when we had that, it was in the Node.js community where people, there was this person who had a very popular library called LPAD, and then at some point he decided, you know what, I want to remove this. It's not open source anymore. He deleted his account, and then suddenly the internet, the hell break loose because everyone depended on that package. So after that event, I started really thinking about how much we essentially became lazy. And I think it's one of the popular Go adages that it's better a little copying than a little dependency. So how much? Sometimes you need to draw the line and say, okay, I don't want to write an entire HTTP router. Okay, I'll add this as a dependency, assuming it was not on the standard library. But for simple things, I prefer to not depend and have a more stable environment because of that, because it's less moving parts. Essentially, it's about that.
Okay, thank you.
Okay, one more?
Yeah.
I just wanted to add to the no dependency thing. From a cybersecurity point of view, I have to take care of stuff in production, and trying to immunize yourself from supply chain attacks is a really big thing now. Most hacks these days come from supply chain attack, and these could be anything from poisoned caches, stuff that you have absolutely no control of. You could write the perfect Go code, but even the things just injected JavaScript, things like that. So just being aware of your attack surface, and the best we can do as Go devs is just try and use no dependencies, or at least just copy paste things that you do want. So it's just a tidbit to get out there.
Yeah, this was also one of the points of one of the refactor steps of not using the standard library default muxer as well. Like, imagine you imported a malicious package that could anyone can register a handler there. So it could register a handler that will expose part of your system. Maybe, of course, it will need to be a very complex orchestrated attack, but it's definitely possible. So the more control you have, the less moving parts, the less smaller your attack vector is.
Okay, thank you. We do have 9 minutes left, so if anyone else wants to ask a question, now is the time.
And if not, we'll be there at the booth, so come to see us if you want to chat. And thank you very much.
Yeah, thank you, Daniela.